right, section 10.5 is over solving quadratics by completing the square. I told you this one was coming yesterday. And completing the square requires that we understand what it is to be a perfect square. And a perfect square, remember, is one that can be, that looks like this: x plus a number and then the squared on the outside. Or it might be a minus sign and the squared on the outside. These are the problems where we saw that we had double roots, or we saw that we had two quantities that were exactly the same. But now we're going to have to, right? X minus 3 times x minus 3, for example. And I told you on the test you didn't have to change. But now we're not even going to get to that x minus 3 twice step. We're going to go right to this perfect square. So when we look at this, let's look at question number 1. First of all, the directions were a little bit off on your sheet. Notice I changed them. Factor the trinomial to create a perfect square. So that when we look at this, we're looking for duplicate quantities. So the only way to get x squared, doing something times itself, is x times x. How about the only way to get 4, doing something times itself? Good, hopefully you said 2. And now we just have to check. I should have an addition sign because the b value is positive. And I just need to double check that if I do x times 2 and then double it, do I get 4x in the middle? Again, my check step is x times 2 and then multiply by 2. And I should get the bx term. I'd like you to give number 2 a try on your own and then come back and check your work. All right, so hopefully you came back and you're checking your work and you did a subtraction sign and you used a 5. This step that I have down here is really just a thinking step that I wrote out so I could check my work. But remember that I always do the first term times the second term times 2, and that's what should give me that b value. Number 3 I thought we would probably need to do together, because when we have a fraction, we don't usually think of that as being a perfect square. So the only way to get x squared is x times x. And 1/4, what times itself would give me 1/4? Well, you could kind of do a square root of a fraction, right? That's what we're thinking in our head. And we can always treat that as the square root of 1 over the square root of 4. And hopefully this problem now looks nice and easy. We would have a 1 over 2. Our b value is positive, so we have a positive. And in our head, we're checking that if I do x times 1/2, first term times second term, times 2, that's going to give me a 1x. And yep, that's what I had in my problem. Now, the cool part, and the reason that we went over all of that, is so that we could go ahead and use that along with solving by square roots, so that we can do these problems down below here. So, whoa, stop scrolling. There we go. Maybe. So, the first thing we're going to do is we're always going to examine our trinomial, because sometimes we'll already have a perfect square trinomial. So, is it possible to create a perfect square? X times x, and it would be 2 times 2, and it should be an addition sign. And if I do x times 2 times 2, yep, I get 4x. So I can jump right to that perfect square. Now, just like we had yesterday, once I have a quantity squared and my directions say solve, I can use a square root. So we do the square root of my quantity equals, don't forget your plus or minus, square root of your number. We do it because a square root undoes something being squared. X plus 2 equals plus and minus 5. And then I need to solve for x. So I'll subtract 2 from both sides. x equals -2 plus and minus 5. So if I do -2 plus 5, I get an answer of 3. And if I do -2 minus 5, I get an answer of -7. No graphing, no factoring, and I came up with my 2 possible solutions. That is solving by complete the square. In a nutshell. Would you please give problem 5 and problem 6 a try, then come back and check your work. All right, so you should be checking your work for numbers 5 and 6. And then now we have kind of a question about what's the pattern that you see, and hopefully you're kind of thinking, well, that's a silly question to ask, but what's the relationship between B and C? Or how can we see them? And I think that that's pretty obvious, or at least it should stand out to you. But when they ask this question, because I know we do it on the quiz as well as on the test, and I think there might even be one on the exam, find the missing C value that will make it a perfect square trinomial, then factor it into a perfect square. It's actually easier to do a little bit backwards. So we're going to create our perfect square. And what's that multiplier? What stayed the same every time we did one of these problems? It was that check step that we did the first term times the second term times 2. So as long as we have a plain x squared or a 1x squared, right, that leading 1, then all we'll have to do is divide the b value by 2. So in this case, positive 16 divided by 2 would give me an 8. And we've factored it into the perfect square. And to find c, we simply need to go back up and say, well, what would 8 squared, right? That's my second term. And my c value is always my second term. My c value is always my second term squared. So in this case, my second term is 8, and 8 squared means that c is equal to 64. Let's try number 8 together, because it's a little bit awkward. We would say, okay, it's got a leading 1, so the only way to make x squared is x times x. -3 divided by 2. Just leave it as a fraction. -3 halves. So there's my perfect square. And now to find c, I need to do that second term and square it. So I need to do -3 over 2 times -3 over 2 to get my c value. And with a fraction, it might be helpful to write it out, but we end up with a positive 9 over 4. Hopefully once you get into the habit of doing these, you won't need to write it out, or you'll be able to think about it like this in your head and not write it out physically. But it's always a good thing to have in our notes. Why don't you give problem number 9 a try and come back and check your work. Just a reminder, and I showed all my work about dividing a fraction by 2. That's really the same as multiplying by a half. Don't forget to reduce your fractions to get that second term. Remember that this set of directions always has 2 possible answers. We're going to talk next about how this can help us, but I'm going to put it in a second video because it's a little bit longer and I want that all attached together. So see you in the next video.